Seems to be a live here, guys. We'll wait for a couple of seconds. And yeah, we are live. तो सी आज हम करेंगे मैराथन स्टार्ट करेंगे फॉर डीटी पार्ट वन ओके इसमें क्या क्या होगा लेट मी जस्ट समर अप PYQs एंड एवरीथिंग व्हिच वी वर प्रिपेयरिंग ओके तो PYQs में आई स्कीम की जो पेपर्स है मतलब जो सैंपल पेपर्स है व्हिच वी आर हैविंग नाउ विद अस वी आर गोना सी दिस लाइक the important questions, okay? And second, जो DT का एक पेपर है मेरा एक सैम्पल पेपर ऑफ कॉलेज सेकेंड यूटी we are going to discuss that, okay? So where I have got like 30 out of 30. And yeah, now let us start. See, for 2 marks, as we can see here, what is done here? Just a normal thing. This much. Nothing else. Just that much. If you want, you can like observe a bit. So like as we can see, this is the T marks. For 2 marks, that's necessary. Like this much is necessary. Okay. Then for again 2 marks, application what is the necessity of multiplexer? Exact. So that we have wrote here in 4 points, as we can see, even the keywords have been highlighted. Okay. And then there was a question like what will be the number of flip flop required for 16 pulse clock pulse. So which we have used the formula and shown it for 2 marks again. Then difference between RAM and ROM for 2 marks, where 5 points has to be like written in case your 1 point has been wrong, so that can be covered up. Then again, a difference between half adder and full adder. Here I have written mistake. Here should be carry in, not present. Like see this not thing. Now, like then to have got 2 marks. How do I have got 2 marks then to here? Due to 6 points which I've wrote. Even your 1 point is wrong, you will get approx the half of that. Like example, if my 3 points are correct and one is wrong, I'll get one and a half. Okay, so that's how it works. Then, as we can see, everything like the diagram and everything which is necessary is present here. After that, the 4 marks question, where we have to make 16 by 1 marks using this 4 by 1 4 marks. So as we can see, number of inputs, there are total 0 to 15 inputs, correct? Which is again number of input, which is 16. Then output, as we can see here, then selected input, yeah, everywhere. After that, this is the final answer. Okay. Then there was like explain for 4 marks what is 7 segment decoder and what it exactly. I have wrote here and highlighted the keywords, nothing else. Okay, then we need a diagram which is not clearly visible, but yeah, this diagram. Now, how the 4 marks has been bifurcated here, like we'll just have a quick view. Okay, so 1 marks for this, 1 marks for the diagram, 1 marks for the truth table, which is approx of 20. Sorry, approx 10 lines, 10, 12 lines, 10 or 12 lines, and then 1 marks for your this final conclusion. What is exactly happening? Okay. After that, what is the application of shift register? We have to write for 4 marks. I have wrote the 4 marks, okay, like 4 to 5 lines for each point, okay, and at the last we have to conclude that why it is exactly necessary and all, okay. After that, the second last question, the JK flip flop. We have to show that how it is exactly working and all. So how the 4 marks has been exactly divided here. Let us have a look. 1 mark for the symbol, or if we can say half mark for the symbol because it is too easy as compared to anything else. Yeah. So we'll write here half marks for this, 1 marks for your this part, then again half marks here for your truth table, and then the remaining part, which is again 2 marks, is for your theory. This is how 4 marks has been divided here, bifurcation. Then last question of today, full adder, correct? Like the full adder part. So as we can see here, how things have been done here. Now let us move to our main part, which is paper solving. Today we are gonna just solve only 2 marks questions, okay? 2 marks and some of basic questions of 4 marks. So now let us move here towards the solving part. Now what is happening here? They have told us to make a part where we have to convert this DSF, sorry, D8S, which is in 16, okay? The base 16, we have to convert it into binary and as well as octal part. For that, what are we going to do? First step, if we are converting this into binary, so first we'll write the, what do we say, binary code of them. Like D binary code is this. Now how it is exactly, if we can see properly, we know this 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. This part means 0, 1, 4, and 8. Okay, now what is the value of D here? Okay, 8, 9, sorry, a bit mistake, guys. Yeah, 2 and 1. Okay, so what is the value of D here? So it is approx 30 if we see properly. Okay, and then 8 we know F, it is as usual, which we know, like 16, 0 by 16, the base 16, sorry, 0 by 15, but it is counted as 16. So there is a number from 0 to 9, and remaining are all alphabets from A by F. I think so this is clear to everyone. This is how the 8 and F has been given the binary numbers. Then we have converted and wrote everything here. That's all. 4, 4, and 4. Okay, now second, this is the binary part. Now we'll move to the octal part. What are we doing here? In octal, we are dividing everything in the part of 3. Okay, the numbers which we have got here. Where do we have got the numbers? This part. We are dividing it here. Just in the part of 3, nothing much. Okay, after dividing them, we are writing the code which we are getting, like 110. If we see a 110, it is giving 6. Same. 111, which is giving 7. So we have wrote this number and this is our what? Octal number. I think so this is clear to everyone. After that, we have to draw the symbol and truth table for the logic equation of XOR gate. Now, first we have wrote the symbol which is this for approx 1 marks or half marks, which we can see. Okay, half marks. Then the equation which is this, the most important part. Again for half marks, and for 1 marks your truth table. This is how 2 marks has been bifurcated here, as we can see here. Okay, then what's the De Morgan's theorem? This question usually comes in exam. Um, okay, so this question usually comes in exam for approx 4 marks, but here it has came for 2 marks. Even it can come for 6 marks, okay, depending, but mostly comes for 2 and 4 marks, okay. So here, first we have wrote what is De Morgan's theorem in theory part, then we have shown the equation, okay. Second, theorem, and then equation, that's all. Half marks each, we can see it. First 1 mark, second 1 marks. After that, we have to convert the given equation into SOP form. Okay, sum of product. The full form of SOP, sum of product. Okay, sum of product. So what are we going to do here? This is the equation which we have got. See the missing values. इसमें missing क्या क्या दिख रहा है? Like इसमें missing क्या है? C missing है. इसमें missing है B. इसमें missing क्या है? A missing है. So we have wrote there कि first product term, second product term, third product term. अभी जो missing part है उसकी जगह पे what we have added just one. Okay, every part. Now we have did the cross multiplication. मतलब we have divided A with 1, then B with 1. Okay, I think so. This is clear to everyone. But keep this in mind, instead of 1, there is the C. Okay. Matlab, what are we doing here? Let me just show you once. So, this is our equation AB multiplied by C. So, what are we doing? AB in bracket C plus C dash. Now, instead of this 1, we are doing this. So, for a cross multiplication, if we divide any multiply any number with this, we know we get C and the dash number. Okay, this is the logic we have read in our chapter number 2 and 3. After that, same with this B and A. The missing values will be like this. Now we'll add we'll do the basic thing. Like AB is multiplied with C and we have wrote here. Then AB is multiplied with C dash, which is written here. Like everything, six values will be there for those three values. The three terms, there will be six terms. After that, we'll simplify this in a better manner. Yes, equals term will be cut. Like this is equal, even this is equal. It has been cutted. Okay. Again, this is equal. We have cut this and this. So this is how it exactly works. I think so. This is clear to everyone. And then this is our SOP form. See, this is the formula which I was telling. Okay. Then after that, draw a symbol and write the truth table. See, this question came in our question bank as well as in our UT, and which I have like shown you now only. But yeah, we'll explain you. First, we have wrote here D. D is the input which is going, and the output is Q n plus one and Q dash n plus one. Okay, then this is the CL clock, also known as CLK. I think so. This is clear to everyone. The short form CLK. After that, this is the truth table for this, where what is our main thing? D flip flop, and here it is a T flip flop. Okay, so this is D and this is T flip flop. Everything is same, just as we can see the input and output are being a bit different here. Okay, now we'll move to the next. Write down the number of flip flops which are required for 16 count pulse. We have first wrote here the given part, okay, which is given in our question. Then the formula which is required, correct? The formula. After the formula has been done, now we'll move to our next part, which is this key, what exactly it symbolizes. If it is n in our formula, so it is like number of flip-flops required. If it is m, so it is number of states. After that, we have substituted those values from above, and we have got the answer for flip-flop, which is like required for a 16 clock pulse. I think so. This is clear. After that, the next question is write the types of DAC. Okay, so there are mainly two types. Even this question has been came in our question bank. Okay, so binary weight DAC and R2R ladder DAC. Okay, after this, okay, 10 minutes. After this, perform the subtraction using second complement. So yeah, let us do the second complement part. What are we doing here? First, we have converted this 52 into a binary part. I know this is pretty much easy. I think so. Yeah, guys. After this, 65 into a binary part. Except this, there are more easy ways as well. And this is also fine, not an issue. After this, we have got two values, 52 and 65. Our question was 52 minus 65. And at the base, there is 10. Keep this in mind, okay? The base 10. After this, we have wrote the values 52, the binary of 52 which we have wrote here, and the binary of 65 which we have wrote here, which is again question mark which we have to find. So for that finding, what we did first, we have wrote the number and added one in it. Okay, adding one in it, and then we got a particular answer. Correct? We have wrote it here and again added it with a which answer? This answer. Now, why we did this? Instead of subtracting it, we have added it. मतलब जब भी हमें कुछ add करना रहता है, we always do this plus one. So it just get normal, okay? Then we have wrote this answer here and adding it with this number, with this binary part, okay? After doing this, what we have did here, first we have converted this into this. What does it mean? First complement means flipping all the bits. Flip bits means if it is zero, it will be one. Yeah, if it is one, and it will be zero. Basic logic of first complement. Second complement says will always add one in the existing number or the bits. After this, the answer which we have got applying first and second complement will be added. And after adding, as final carry is not generated yet, the result is negative and it's second complement form. Example, to get a final answer, take second complement of result. In short, we have to do this process again. So this is our answer at last. After doing the process, this number which we have got here has been again taken and added first complement, second complement. After that, we got an answer which is here 1101 to the base 2. Yeah, guys, I think so. This is clear. After this, I will move to this question simplify the Boolean expression using logic gate. Yeah, so let us do this. One of our easy questions. Here, what are we doing exactly? The equation which we have got here. It is again simple. Yeah. Like for 2 marks, we have to write the equation. For 2 marks, we have to implement using the logic diagram. Now, first, we can see here this D dash can be wrote as like this as well. Now, everyone must be like, what are you saying? I'm not like understanding the part. So what we did, this D, now let us remove some common part, okay? Let me just remove this common and highlight the main part, which is required. So as we can see here, this normal D and this D, okay? After that, this D and this D, which is again here in the common part. After removing the common, what we did, this is common, correct? Which we have wrote here. After that, what else is common? So this ABC and ABC. So we have wrote here the basic logic, nothing else, okay? After that, what we did, we know that this is equals to 1, the formula, okay? So we have applied this formula here, and now most of the people will like, what is the formula? So this is the formula. After this, we know multiply any number with 1, we always get that number. So we have got this. And after this, we even know we are removing the common again, this part here. And it is here now. Again, same rule. This, if it is there, then it will be what? Again, the same alphabet. So it is now A and B. So what is the answer of this question? This was a question. मतलब ये अपना question था. What was this question? Boolean expression. We have simplified it and got the answer A into B. Now we have implemented it using the logic gate, which is again for 2 marks. So we have wrote here A, B, two inputs, and the output is only Y, which is A into B. This was for 4 marks, basic. Okay. After this, now we'll move to our next part, which is this K-map part, where we have to use some logical functions of the variable and implement the K-map. So first we have got this A, B, C, D, those things. And there are some of the things which we can see like 0, 1, 2, 3, 4. Last time we have read this everything, how those are being evolved. Yeah, there are the truth table and everything behind this. Before that, we'll just see those numbers 0, 0, 0, 1, 1, 0, and 1, 0. 0, 1, and 1, 0. Those are the numbers same on both sides. Okay, horizontal and vertical both. After that, here we have wrote AB in this side CD. Now, the numbers here we can see are the one, like see 0, then there is 1. Let me just write this with the red part. Okay, then 3 here, 2 here, after 2, the 4 parts come here, 5, 6, 7. Now, what are those numbers? See, 0 is 0 present, yeah, so we have wrote 1. Okay, 1 we have wrote for 0. Then 1 is present, again we have wrote 1. Then 2 is present, so for 2 we have wrote 1. 3 is present, we have wrote 3. Is 4 present? No, 4 is not present. So empty. Is 5 present? Yeah, so we have wrote 1. 6 present? No, so empty. 7, so 1. So the number which is present here. So we have to just mark 1 here for that number and nothing else. After this, what are we doing? We are writing the equations or the part of thing which we are getting from this key map. Okay. And we are implementing all of those in our equation, nothing else. This was for initially 4 marks, nothing else. Yeah, guys, मतलब हमने इतना ही किया. So how things are bifurcated here? Key map is for 1 marks, okay. Second, to make the pairs, and third, to write the answer in a proper structured manner. Okay. After that, Implement the function using demultiplexer. These are two of our things. Now we'll use the demultiplexer. Two equations which we have got. So we have wrote all of them. Now this is a logic which is 1. Here it is our stroke or the enable button which we can see kind of. Okay. Now here are ABC. ABC. What are those? Those are select input. I think so. This everyone knows this select input. Yes, select input. Okay. After this, those are some of our outputs. This is the input side, and this is the output side. Correct? After getting the outputs, we have implemented the logic gate here directly. I think so. This is clear to everyone what we did. We just implemented the demultiplexer. What it does exactly says there is only one input and 8 outputs or 4 outputs depending on the demultiplexer. Yeah, guys, nothing else. After this is for 4 marks. Now, most of you will say, like, what is this? We are not understanding it. So, for them, let us see the output part properly. Okay, again, here, what is y0? We have added the y0, then 4, like 2, 4, 6. Y0, Y2, Y4, Y6. This is giving us the output as F1 after using the logic gate. Then our remaining lines, which is Y1, Y3, and Y5, which are again odd numbers. We have implemented a logic gate here, which is giving us F2. I think so. This is clear to everyone. Now, the question number 3. How much time has been happened? Okay, I will attempt this. So, question number 3, we have to make a logic expression, okay, using the NAND gate for all of those 3. Okay, this is for 4 marks again. So first, what we have to make, we have to just make the OR gate from NAND gate. Basic, this is the OR from NAND. Yes, guys, 2 inputs and 1 output, even in AND part, AND gate using NAND gate. So this is the NAND and this is the NOT. Okay, NOT. Okay, got it, got it. Then it was for 1.5 marks. This is for 1.5 marks. Yes. After this, we can see here, this is a 1 input, 1 output, and that's all. This is how all of us things work. So we have got how much marks here? 4 marks. And we have to even explain this, okay, like how this exactly happening. Now we have wrote this in normal words, but we have to write this in 2 lines each. So 2 lines for OR gate, 2 lines for AND gate, and 2 lines for NOT gate. Okay, output a bar. Okay, so there will be a bar here. Okay, this is our question. Draw binary to Greek converter and write its truth table. Okay, so this is our thing, which is again for 4 marks. As we can see, here is K map is optional if it is there. 2 marks is for truth table, which is again a use table. Then the K map, and after K map, there is the logic gate. As it is mentioned here, the K map is optional, but yeah, in terms of learning, we'll learn everything which is given here. Now, what we have to do, if we can see properly, 0, 0, 0, 0, giving what? 0. 0, 0, 0, 1, giving us 1. Yes, again, 0, 0, 1, 0, giving us what? 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. I think so अभी सबको समझ रहा है what it is exactly. These are the binary numbers from 0 till approx 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15. Till 15, 0 to 15, those are all binary numbers. Okay. Decimal binary, I think so everyone knows. After that, what we have did, we have just wrote the gray output. What is the gray output for 1? For this. For 2, it is this. In this manner, we are working here. Okay. After that, we have wrote the K map. K map matlab, is this number present or not? If present, then right. If not, then add 0. bus, nothing else. Same, this was for G3 and this is for G3, B3 both. After that, we have got some equation here, which we have wrote. Okay. One means present in the question or in our truth table. Zero means not present. Okay, I think so this is clear to everyone. After this, again, same. We have writing this for B3 and B2, B1 and B0. This is now you will be like, what is B1? What is B2? This is mainly from grayscale. Okay, grayscale. I think so. You should see our previous videos. But the one who doesn't know, grayscale is like exactly you are converting that number into another form where all those things, steps is being happened. So this is the K map for that steps exactly. After that, we have made a diagram for 4-bit binary to gray code converter, where what we are doing, there are four of our binary inputs and four of our gray outputs. Okay. In this manner, things have been happening. Now, here one thing is given to us. Note, realization of output equation can be done using basic or universal gates, depending. Yeah. Again, describe the working of JK flip-flop with truth table and logic diagram. Now only we have saw in our paper as well. So this is how things are working. Truth table and a detailed thing for 2 marks. Okay. Now, what is happening here? J. I think so. Everyone know what is happening here. For that, let me just open this. J. Yeah, guys. Here, as we can see, J is a set. CLK is clock, also known as edge triggered. I'm not using this answer, okay, guys. I'm using this answer because I don't know. This is a bit lengthy and not useful, I think so. But yeah, teacher usually, examiner usually see those parts while checking and keywords which you have to highlight like this. So J is set, CLK is clock, K is reset here. Okay. Now what is happening? This is the flip-flop part, which we can see here, this one. And this is the highlighted next part beside that is the SR flip-flop. Okay. Now SR flip-flop, how are you exactly saying? Most of the people will be saying this. So see, as we can see here, this is as shown above. Okay. And the outputs, it can be this and this as well as like this. Okay. After that, the truth table, which even I have wrote here, correct? Now, we can see here one part. Okay, Anna, this is correct. I was like, what is this? But yeah, 0, 1. So 0 and 1 is giving 0. Okay. And 1 and 0 is giving 1. Okay, properly. After that, we have wrote 4 points. Okay. 3 to 4 lines for each point here. 3 lines, 3 lines, 3 lines, and yeah, a bit bigger to show the length of the answer. Okay. Here, the clock has been passed here, which is again going through AND gate to SR flip-flop. Okay, from JK flip-flop, it is going to SR flip-flop. And in SR flip-flop, as we can see, the NOT gate has been applied where this toggle mechanism, CLK, clock, which we can see here. Then after that, we are getting those outputs QN and this QN. But the toggle mechanism, what is it exactly doing? The toggle mechanism means if the output doesn't change until the toggle is in front. Means if the toggle is in front like this, wait, see here, like this. If it is in front, the output will not change. Okay. But instead of that, without CLCK edge, the toggle cannot trigger and display output. मतलब जब तक वो ट्रिगर नहीं होता है डिस्प्ले बिल्कुल नहीं दिखेगा बस इतना ही था ओके एंड या what's the timing now? Okay, now we'll move to our this last question of today. Okay, question number 3, the last question. Describe the working of 4-bit SISO serial in and serial out. Shift register with diagram. Okay, and waveform in input. So this is the FA, FFA, FFB, FFC, FFD. All same. Okay. Now After that, this is a CLC key, clock, which we say here. This is serial data in and serial data out. डेटा आ रहा है और जा रहा है, बट कैसे जा रहा है? सीरियल. After that, this is a D and this is a Q. Then 0101 as usual, where the clock has been shown. After that, we are showing you the working, how it exactly works. Means it takes one bit from here, then it enters to the C. The CISO is a shift register in one of the simplest way. The full configuration, as it is only three connections. It is having only three connections. The serial input, which determines the enter left hand flip flop. Okay, मतलब this is the right side and this is the left side. Left side से वो flip flop जाएगा and the serial output SO, okay, which is taken from output of the right hand. Right hand से आएगा output, correct? Basic things have wrote, but in a technical or the electronic manner, which we say the words which is required, and the sequence, the CLCK, sequencing clock signals. The logic circuit diagram below shows a generalized serial input. मतलब ये सब जो है एक serially input sorry serially मतलब एक कतार में kind of output दिखा रहा है in a proper line where FFA is giving Q4, FFB is giving Q3, and so on for all of four of those. After that, we are showing the waveform, which is again basic. Now, most of you will be like, what is this exactly? And from where this input comes, correct? 0, 1, 1, 0, 1. So this input is usually coming from the question 0, 1, 1, 0, 1. On the basis of that, we have wrote it correct 0, 1, 1, 0, 1. And after that, we have wrote 1, 2, 3, 4, 5. All five things, the clock, which we say clock, correct? Here it is 0 at the base. At the top it is 1, as we can see here. Okay, 0 and 1. As we are seeing further, those numbers are getting a bit normal. Yeah, a kind of this. Correct? So this is how things are working. And I hope everyone is understanding. So we'll end our today's lecture here and we'll continue next lecture, like next part from tomorrow here. Okay? Question number 4. So bye guys. Have a good day.